This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will look at importing and plotting experimental data in MATLAB. You may have collected data in a lab and wish to import it into MATLAB to plot. There are various methods of importing the data into MATLAB. If you don't have a large volume of data, it may be easier to enter it into the command window by creating vectors and arrays. But for larger volumes of data, you might, for example, want to import it from an Excel file. In my current directory, I have an Excel file called Concrete Beam, which contains some data from an experiment that I want to insert. Before we import this data, let's open the file in Excel, which we can do directly from MATLAB by right-clicking on the file and choosing Open outside MATLAB. This Excel file comes from an experiment in loading a reinforced concrete beam. The load was incremented in 2.5 kilos, and we recorded the central deflection using 2 transducers. Now, leaving Excel, we will continue to import this data into MATLAB. We complete this by using the import wizard, which can be found in the toolbar and is simply called Import Data. I choose the Concrete Beam Excel file, and MATLAB launches the import wizard. It is clear that MATLAB had recognized the data from the Excel file. It is actually shown in a very similar manner to Excel. What we want from this data is the raw experimental data. So we can select the rows we wish to import into MATLAB and click the tick at the top right corner. Once we have done this, you will see that MATLAB has produced 3 new variables in the workspace and named them deflection 1 mm, deflection 2 mm, and load kilonewtons. We will now close the import wizard and start to plot the data. Before I move on to plot it, I want to save these variables in a MATLAB file, so if I need to use them later in another MATLAB session, then they won't need to be imported again. Selecting all the variables, deflection 1, deflection 2, and load, I right-click and choose Save As. I can then save these files in a MATLAB file in my directory under the name Concrete Beam. In the current directory, there is now a MATLAB file called Concrete Beam, which contains these variables. We can now go ahead and plot the data. Using the plot command, we first plot the load against deflection 1, and then the load against deflection 2 as the second trace on the same plot figure. However, this has returned an error because we haven't input the variable names correctly. We use the up arrow and alter so the command shows the exact names. It is always important to pay attention to capital letters, since MATLAB may not recognize an input simply because you have used a lowercase letter rather than a capital, or vice versa. Once the command has been entered, the plot opens in a new window. We will now open the interactive plot tools to annotate this plot. Firstly, we will label up the 2 traces, deflection 1 and then deflection 2. I also wish to remove the line from these traces and add discrete markers, as this is often what you need to view from your data. I will also label the x-axis, load, with the units kilonewtons, and the y-axis, deflection, in millimeters. We will also title the plot. And finally, we add a legend to the figure by selecting the Insert and Legend option. However, MATLAB has placed a legend over one of the data points. You can correct this by selecting the legend and changing its location to a more suitable position. Now we have finished annotating, we can turn off the plot tools and save the plot. Remember, it is always good practice to save a .fig version of the plot so that we can edit it in the future. In addition, I will also save a JPEG file so I can use it for a report. And this is a simple example of how to import experimental data into MATLAB. Select the relevant information and produce and annotate a plot. Finally, I would like to show you another method of plotting data. Closing your previous plot and selecting the Plot tab in the top left corner of the GUI. It displays multiple options for plotting your data. If I select all three variables, making sure I select the load variable first, since this is what we want to plot both the deflections against, I can use the button Plot as multiple series versus first series on same plot. This allows us to plot a second and later series against the first series on the same graph. You can see that it plots the same graph as before, and that we can annotate it in the same manner. Using these tabs and quick buttons is a useful method of completing tasks, but I would always suggest learning the input commands, as in the long run they save you time and allow you to have a better idea of how to use MATLAB.
This production is copyright The University of Edinburgh.